Hi and welcome back to another video. This time I have an old school amplifier made by MTX. I am talking about the MTX Thunder Pro 300X2, which was made in 1998. The amp is rated 150 watts into a 4 ohm load and 300 watts into a 2 ohm load of continuous power measured at 12.5 volts. They rated the amplifier dynamically 750 watts mono into 4 ohms. The MTX features 3 fuses, 30 amps each. Here are the connectors for battery plus, remote and ground, and also the speaker connectors. You can see the terminals you should use if you want to run the amplifier in bridged mode. On the other side of the amp we have a gain up for each channel, a bass boost, a high pass filter and a low pass filter, which are adjustable in frequency, and the RCA inputs and outputs, and a connector for a bass remote. Is there a difference to the Holy Grail, the Thunder 2300? Yes, there's a huge difference. Let's check it out together on the ampdyno. The Blue Thunder Pro 300X2 is connected to the dummy load resistors. I got 2 resistors, 3.9 ohms each, bridged mono 8 ohms, 7.8 ohms, connected to the amplifier. Amplifier is connected with a short wire to my power supply, a Mandorf power supply, which delivers around 150 amps at 13.6 volts. And I use my scope. And for the input, I have my external USB sound interface. And now we can start with 1 kHz or 50 Hz continuous power test. Continuous power test with a 50 Hz input signal. The fan of the amplifier gets off, turns on, clipping. It says 96 volts. Let's calculate with 93 volts because we have a little bit of distortion. Take another try. Not easy. And now we have a clean signal and we can take 93 volts. The amplifier is rated 150 watts per channel into a 4 ohm load, and in this case the amplifier delivers 277 watts into a 4 ohm load per channel, both channels driven into full power with a 50 Hz input signal. Continuous power test, this time with a 1 kHz input signal into a 4 ohm load per channel. Amp is rated 150 watts. It says 97.2 volts. I take the peak voltage. Let's calculate with 93.6 volts. The amplifier delivers 280.8 watts into a 4 ohm load per channel, both channels driven into full power. Dynamic power test with 1 kHz burst, 20 cycles. Here my cycles are at the same voltage level. I take the last cycle. You can have a look at the first cycle. Got a peak voltage of around 94.8 volts. Go to the last one. Reduced by 20 dB. So I got a peak voltage of around, I would say, let's calculate with 94.2 volts. There's no dynamic headroom, almost no dynamic headroom. With 1 kHz burst, 20 cycles, the amplifier delivers 284.5 watts into a 4 ohm load per channel, both channels driven into full power. Here you see the amplifier idling at 2.3 amps. That's not very accurate. With a more accurate meter I had 2.05 amps of idle current. So now I give full power into both channels with 1 kHz continuous power. And the amplifier pulls 55.6 amps. With continuous power test, the amplifier's efficiency is around 74.2%. The power supply delivered 13.61 volts. Now I'm changing the load. I use one 4 ohm resistor bridged mono to the amplifier, and let's see what the amplifier can do. 4 ohms mono, that means 2 ohms per channel, both channels driven into full power. 1 kilohertz continuous power test. Clipping, fine tuning. Okay, I take this one. It says 90 volts. I think we should calculate with 82.8 volts. The amplifier delivers 439.6 watts into a 2 ohm load per channel, both channels driven into full power. That means almost 880 watts mono 4 ohms. Continuous power test, but this time with a 50 Hz input signal. Clipping. Can we take this? Yes, we have some kind of distortion here and there, but I think it's correct if we take the peak voltage. It's not easy to adjust it. I can take another try. That looks dirty. Yeah, this looks much better. So it says 86.4, that's not true. You should go with 80.4 volts. With a 50 Hz input signal, the amplifier delivers 414.5 watts into a 2 ohm load per channel, both channels driven into full power. That means bridged mono 4 ohms, around 830 watts almost. Dynamic power test with 20 cycles. We can calculate with 85.2 volts. The amplifier delivers 465.5 watts into a 2 ohm load per channel, both channels driven into full power with a dynamic burst signal IHF202, which means 20 cycles full power and then 480 cycles reduced by 20 dB. That means the amplifier delivers around 931 watts into a 4 ohm bridged mono load. Now I do the 8 cycles test. That means we have a burst of 8 cycles and a pause of 32 milliseconds. So I give input signal and I going to check out the last cycle, of course, because it's possible that the first cycles are higher and then they get clipped and lower. So I need a clean last cycle. That's the last cycle. Slightly clipped. But I take not 91.2 volts. Let's calculate with 87 volts. With 8 cycles, the amplifier delivers 485 watts into a 2 ohm load per channel, both channels driven into full power. That means we have 970 watts mono 4 ohms. And now, just for fun and for demonstration, I show what the amplifier can put out short-term wattage. That means output power for just 1 millisecond. I catch the cycle. So I take the peak voltage and we have 94.8 volts. For 1 millisecond, the amplifier is able to put out 576 watts into a 2 ohm load per channel, both channels driven. That means bridged mono 4 ohms. We have 1152 watts. And now I start to give full input power. 93.9 amps, 94 amps, 93, let's calculate with 94 amps. I calculated an efficiency of 69.1% if I use a continuous input power signal, and if I use my dynamic burst 20 cycles, I have an efficiency calculated of 73.2%. The power supply was able to deliver 13.53 volts. Just for testing, the amplifier is not rated to handle a 1 ohm load per channel, 1 ohm resistor, 2 1 ohm resistors in series, which is 2 ohms connected bridged mono I'm starting with a continuous power test, 1 kilohertz. Let's have a look what the amplifier is doing with 2 ohms mono. Oh, no way. 2 ohms mono continuous, he doesn't like it. Bam, he shuts off. I'm switching to dynamic power test. Dynamic power test, I'm going to take a burst, but you can see here it goes dramatically down. So I have to reduce input signal. This also does not look nice, so I go to the last cycles. Ooh, dirty, dirty. I reduce input signal. That doesn't look good. This is the cleanest I can get, so let's calculate for fun. We just have 55.8 volts. The amplifier doesn't like 2 ohms mono, not even with dynamic power testing. It delivers 389 watts into a 1 ohm load per channel, both channels driven into full power. I will do, just for fun, the 8 millisecond test and the 1 millisecond test. 8 millisecond dynamic power test. I observe the last cycle. We get, oh, clipping. You see the first cycles are clean, the last lower. And I go down to the lowest cycle. We have 75.6 volts. The amplifier comes back with 8 cycles. It delivers 714.6 watts into a 1 ohm load per channel, both channels driven. Absolute peak RMS power test, 1 millisecond, 1 cycle, 1 kilohertz. And here we have it. We have a peak voltage, it says 91.2, but I go with my cursor to the top of the waveform. And I think it's fair to calculate with 90 volts. For just 1 millisecond, the amplifier delivers 1012.8 watts into a 1 ohm load per channel, both channels driven, that means bridged mono. 2 ohms, we have around 2025.6 watts.